There is a pattern in history that unfolds so quietly, so gradually, that by the time anyone recognizes its shape, the conclusion is already written into the land itself. Empires have seen it. Ancient civilizations have endured it. Every collapsing ecosystem follows it. It starts with a spark, small, contained, seemingly harmless. Then extraction scales, ambition grows, and the rhythm of nature begins to distort. Eventually, the system reaches a point where not even the greatest power, the most determined will, or the largest institution can reverse the momentum. Here's what nobody tells you. Ecosystems don't collapse all at once. They accelerate toward collapse through a four-stage pattern. And according to some environmental analysts studying Amazon trends, this framework, if you accept its premise, may suggest the forest could approach a tipping point as early as 2028. This is where the pattern begins. In Stage 1, ignition, a forest is too vast for humans to understand as fragile. The Phoenicians believed this in the 1200s BCE when they cleared cedar forests for ships. The Greeks believed this in the 7th century BCE when they harvested wood for metallurgy. The Romans believed it across centuries as they expanded from Italy into the Mediterranean basin. Trees felt infinite. Soil felt endless. Rivers felt eternal. But every ignition stage always hides the same mechanism. The first cuts don't reveal the damage. The early losses look like progress, prosperity, and expansion. At first, it looked like a miracle. Then the bill arrived. Let me show you exactly how it happened. Historical case number 1 begins in the ancient Mediterranean. By 800 BCE, Greeks cleared hillsides to grow olives, grapes, and wheat. Timber was exported across the region. For a century, it seemed harmless. But the ignition stage morphed quickly into Stage 2, expansion. Extraction scaled. Shipbuilding intensified. Agriculture moved upslope. Each year, a little more soil washed away. Streams grew narrower. Floods became more violent. Here's what nobody tells you. The Mediterranean today, with its bare hills and thin soil, was once covered in dense forest. Civilization didn't notice it dying until the land had already passed its natural threshold. Not growth, overreach, not abundance, decline. By the 2nd century BCE, Rome dominated the region, and Stage 3, distortion, was in full force. Forests that once retained moisture now baked under the sun. Rivers dried faster. Rainfall patterns shifted. Small farmers abandoned degraded land and moved to cities. The ecosystem didn't fall suddenly. It deteriorated gradually, predictably, and irreversibly. This ancient collapse matters because it shows the shape of the pattern. Early extractions offer wealth. Increased demand accelerates loss. Natural systems weaken. A tipping point arrives. And once the tipping point passes, the land becomes something it was never meant to be. You cannot reforest an entire climate once it crosses that boundary. To see how this same pattern repeats, we begin historical case number 2. The destruction of the Atlantic forest in South America. In the early 1500s, the Atlantic forest stretched across Brazil's eastern coast, one of the richest biomes on Earth. Portuguese ships discovered a coast so densely wooded that chroniclers described it as an unbroken wall of green. The ignition stage began the moment settlers realized the value of Brazil wood, an early economic engine used for dyes. Trees were cut slowly at first, in scattered patches. Nothing looked alarming. Everyone thought they were safe. They weren't. By the 1600s, sugar plantations expanded. By the 1700s, coffee and cattle ranching pushed even deeper. Stage 2, expansion, accelerated faster than the land could regenerate. Entire valleys were cleared in a single decade. Rivers shifted course. Hills eroded into plains. Not protection, profit, not stewardship, consumption. Here's what nobody tells you. Ecosystems can withstand extraction, but they cannot withstand acceleration. It's not the cut that destroys the forest, it's the speed of the cuts, the clustering of them, the fragmentation that follows. This is where the pattern begins to resemble something familiar. By the 1800s, Stage 3, distortion, was underway. The Atlantic forest began losing its internal logic. Moisture cycles weakened. Specialized species vanished. The microclimates that sustained rainfall shifted inland. By the time scientists measured the damage in the 20th century, less than 15% of the original forest remained. A biome that once stabilized large sections of South America had crossed its irreversible line centuries earlier. Which brings us to the modern world, and the Amazon. The Amazon rainforest is not just a forest, it is a climate engine, a water generator, a continental stabilizer. But according to scenario-based studies by various environmental groups and climate researchers, the Amazon may now be moving through the late stages of a familiar pattern. Not guaranteed, not predetermined, but conditional. Let me show you exactly how the parallels form. Stage 1, ignition, began in the early 1970s when roads pushed into the forest interior. Settlements expanded. Logging began. Then came cattle ranching. The loss was small compared to the Amazon scale, less than 1% per decade. Policymakers believed the forest was too vast to be vulnerable. But ignition is deceptive because it hides acceleration. The first cut is never the one that matters. It's the momentum that follows. Stage 2, expansion, accelerated rapidly in the 1990s and 2000s. International demand for beef, soy, timber, and mining surged. Infrastructure expanded deeper into the rainforest. Deforestation jumped from hundreds of thousands of hectares per year to millions. Analysts tracking satellite data noticed something consistent with historical patterns. Once networks of extraction form roads, clearings, and agricultural zones, the surrounding forest becomes more vulnerable, fragmenting like cracked glass. Not isolated events. A system-wide trend. Stage 3, distortion, may already be visible. Multiple environmental reports suggest that certain regions of the Amazon now release more carbon than they absorb. Rainfall in some areas has become less predictable. Dry seasons have lengthened. River flows have changed. Millions of trees have died from heat stress. If the Amazon is entering distortion, it means the biome's internal mechanisms, its moisture recycling, its resilience, its self-regulating humidity, are weakening. Here's why this matters. Once Stage 3 sets in, ecosystems accelerate towards Stage 4 even if human extraction slows. Stage 4, the tipping point, is the moment when the system's self-regulation breaks. Scientists debate the exact threshold. Some models estimate that if deforestation reaches 20 to 25%, the forest may convert into savanna-like vegetation, permanently altering rainfall patterns across South America. And here's what nobody tells you. A tipping point is not a prediction. It is a boundary that becomes visible only after it has been crossed. Ancient Mediterranean societies didn't know they had destroyed their rainfall engine until it was gone. The Atlantic forest didn't know it had lost its regenerative capacity until only fragments remained. According to some analysts, if current trends continue, even with fluctuations, certain zones of the Amazon could approach a tipping threshold by 2028. Not guaranteed, not absolute. A scenario based on current trajectories, economic incentives, and environmental stressors. Let me paint the cinematic shape of what a tipping point means. Rainfall decreases. Fires spread more easily. Regrowth weakens. The forest loses moisture. Rivers shrink. Clouds thin. Each year, the land becomes more vulnerable. Each dry season becomes a test. Each fire becomes a signal. And the system moves, step by step, toward a state where the forest cannot save itself. Everyone thought the Amazon was too big to fail. They weren't. The danger wasn't what they saw, it was what they ignored. the acceleration hidden inside the extraction. And the critical question, the one that determines whether the Amazon stabilizes or crosses into irreversible change, is this. How does a biome as vast as the Amazon behave when decades of extraction collide with climate pressure at the exact same moment? Because the answer is not found in the past, it is found in the patterns. And the second section holds the full shape of that future. To understand how the Amazon could approach a tipping point, we must complete the second historical case, the collapse of the Atlantic forest, because it reveals how quickly an ecosystem can accelerate from abundance to exhaustion once Stage 3 begins. By the 1820s, cities like Rio de Janeiro faced chronic water shortages, something unimaginable a century earlier when the forest was intact. Springs dried, rivers shrank, hills eroded. What once regulated rainfall now generated droughts. And here's what nobody tells you. The collapse wasn't caused by total deforestation. It was caused by fragmentation. The forest didn't die when it disappeared. It died when it could no longer function as a system. Everyone thought they were safe. They weren't. By the mid-1800s, the damage had deepened beyond recovery. Farmers pushed inland. Urban centers struggled with sanitation. The biome reached Stage 4, the tipping point, not in a single moment, but in a series of irreversible consequences that no policy could undo. The Atlantic forest became a relic, a museum of fragments. Less than 15% survives today. Let me show you exactly why this matters for the Amazon. The Atlantic forest collapsed long before it was gone. That is the hidden mechanism repeating itself across ecosystems and centuries. Now we move to historical case number 3, the Aral Sea. In the 1950s, the Aral Sea was one of the world's largest lakes, sustaining millions across Central Asia. The Soviet Union redirected rivers feeding the lake to support cotton production. In Stage 1, ignition, the change seemed small. Irrigation canals expanded, villages prospered. The early decades looked like success. Then Stage 2, expansion, arrived. Cotton exports surged. Water extraction intensified. The Aral Sea shrank by 10%, then 20%. People noticed the retreat but believed it reversible. Not decline. Progress. But by the 1980s, Stage 3, distortion, was visible from space. The lake split in two. Dust storms carried salt across hundreds of miles. Fisheries collapsed. The regional climate shifted. Rainfall patterns changed. And by the early 2000s, the Aral Sea crossed Stage 4, the tipping point, losing over 90% of its water volume. Even when restoration attempts began, the system was too far gone. A new climate had formed, locked into place. Here's what nobody tells you. Tipping points don't announce themselves. They reveal themselves only after they've passed. And that is why analysts examining the Amazon view the 2020s as a critical window, not because collapse is guaranteed, but because acceleration is measurable. Now, let's apply the 4-stage pattern to the Amazon conditionally, with modern compliance framing. Stage 1. Ignition. The ignition began in the 1970s with roads, ranching, logging, and early industrial expansion. Analysts note that the forest appeared resilient at first because its size masked early damage. Stage 2, expansion deforestation, surged in the 1990s and early 2000s as global demand for soy, beef, and minerals increased. Satellite imagery showed rapid fragmentation. One scenario suggests that the Amazon's structural integrity began weakening at this stage, even though tree cover remained high. Stage 3, distortion. Some environmental researchers argue that parts of the eastern and southern Amazon now emit more carbon than they absorb. Dry seasons lengthen. Rainfall declines. Fires become more intense. River systems fluctuate. If this pattern applies, the forest may be shifting toward a destabilized state. Here's why this matters. Stage 3 is the last phase where recovery remains possible at scale. Once moisture cycles weaken, the system struggles to regenerate even if deforestation halts. Stage 4, tipping point, scenario-based. No scientist claims absolute certainty on the timing, but multiple research groups propose conditional ranges. Some scenarios suggest that at 20 to 25% deforestation, combined with rising temperatures and declining moisture, the Amazon could abruptly shift from rainforest to savanna-like vegetation in certain regions. According to some analysts, if current rate fluctuations resume their earlier trajectory, parts of the forest could approach tipping conditions around 2028. Not prophecy. A conditional projection. Here's the trap. People assume that because the Amazon is vast, it cannot cross a threshold within a human lifetime. But thresholds aren't about size. They're about systemic balance. The Aral Sea was enormous until it wasn't. The Mediterranean forests were massive until they weren't. The Atlantic forest spanned thousands of miles until it didn't. Scale delays collapse. It does not prevent it. Let me show you exactly how the Amazon's future could unfold across several possible scenarios. None guaranteed, all dependent on choices, pressure, and response. Scenario 1. Ecological stabilization. Governments strengthen protections. Deforestation drops. Restoration projects expand. International funding supports conservation. Moisture cycles stabilize. The forest recovers slowly. Stage 3 reverses. Scenario 2. Managed retreat. Deforestation slows but doesn't stop. The Amazon partially contracts. Some regions degrade while others remain intact. The tipping point is avoided, but the forest becomes a smaller, more fragmented version of its former self. Scenario 3. Partial savannization, conditional. Under this scenario, certain regions cross local tipping points. Southern and eastern zones degrade into dry forests or savanna. Rainfall declines regionally, but not across the entire basin. The Amazon becomes a hybrid biome. Scenario 4. Rapid decline. Low probability, high impact. Accelerated deforestation. Heat stress and fire frequency converge. Rainfall patterns shift, moisture recycling drops, and the forest enters a runaway feedback loop. This scenario is discussed by some analysts but not predicted as the most likely. Here's what nobody tells you. The Amazon doesn't need to disappear to reach a tipping point. It just needs to lose the delicate internal mechanism that keeps it alive, its ability to create its own rain. And once that mechanism fails, the forest becomes something else, something drier, something weaker, something unable to regenerate at its former scale. Here's why this matters. The Amazon shapes rainfall far beyond its borders. Its fate influences agriculture, water cycles, and economies across the continent. A biome's collapse doesn't stay local, it radiates outward like shock waves. But the pattern is not destiny. Patterns are warnings. History doesn't repeat itself because ecosystems are identical. It repeats because pressures, incentives, and human decisions follow familiar arcs. The lesson is clear. Every ecosystem that reached its tipping point did so because people believed the danger was far away. The Amazon faces no guaranteed collapse, only a crossroads, one that still holds choices. And if this cinematic journey opened your eyes to how forests live, die, and accelerate through time, then the message is simple. To protect the future, we must recognize the acceleration before it becomes irreversible.